1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. Let's see how it looks on. Okay, says I'm live. 1, 2, 3. Ah, of course I'm very quiet today. 1, 2, 3. 1, 2, 3. Okay. So, just check my audio settings. I think maybe it's something else. It's the way to check that. One, two, three. 1, 2, 3. Let's see that. One, two, three. 1, 2, 3. 1, 2, 3. I think it'll be fine. If anybody says anything in chat, I'll be looking. Hopefully, I don't get too distracted. What was it? There. Just remembering my own key bindings. Okay, so today I will be doing some refactorings. Just some light refactorings, you know, easy stuff. So let's see, where are my notes? These are off-screen notes. Well, let's start by writing some tests. Explore. We're going to write some tests. Let's just go here. So we're going to make a test for, let's do global map first. Global map test.cpp. Split this with source. Global map HPP. How does the other tests handle this? Like the new parser test, how does that handle it? It just includes the parser. I think I know why it's doing that, yeah. The way to fix that is to go into build, then open here with the make command. It detects everything, and there's our build. Hopefully compilation doesn't ruin the stream too much. Compile is created. Now I get to edit. Edit test. Let's test global map.cpp. Then vsplit open. source global map. Actually, it would be better to just, I prefer more the test case version, where we say things like something like lookup on an empty map returns a null pointer. Wait a moment. I have another problem. This returns a null pointer. Odd. Hmm. The only thing is that the value type has always been some sort of pointer. I could try to static assert that. I could static assert that this should not be a pointer and then have it as a pointer. Let's see, so we use this for a pointer. Use this on pointers, smart pointers and raw pointers. Yeah. On smart pointers and on raw pointers. Now time to look up C++ documentation. Which means time to pull up an incognito window. Send that over to a different area. And over here, it'll jump here. And, well, not too much anything incriminating, so CPP reference. Oh. Well, I think for now we'll be fine without. I think I'll do this I'll have to do this off screen. So, is there a way to check if something what I need to know is if something can be constructed from null pointer. That's the assertion I want to make. That would be a type trait thing. Feels like a type traits thing. Does support operations. Is convertible. In fact, is no throw convertible, but that's a 20 feature, which I'm not on 20 yet. Okay. Static cast, or static assert. Only use pointers. Pointer-like types for its value. Okay. The way to check that, it seems to be, is use stood is convertible. Is constructible. Huh. That's something interesting. That is just pulling up documentation on a separate screen. is constructible. If T is an object or reference type, the value T form provides the value true, otherwise records the value false. Trivially constructible, but does not call any operation that is non-trivial for the purposes the call to decl val is considered trivial. Question: can a smart pointer be trivially constructed from a pointer? Let's see. It's a unique pointer. You can no-throw construct from a pointer. Okay, that makes sense, but what about shared pointer? Shared pointer, I expect some sort of trickery here. No, shared pointer can construct freely from a null pointer. Well, I can use is no-throw constructible. Is no-throw constructible if this value type that we have here is no-throw constructible from the null putter type, yeah, there, look at that. It's a long one, but we can say that. Hopefully it looks to be fine. Yeah, that looks to be fine. Global map. Return false if the ID fail lookup if the module does not exist. Well, that's easy to write. I just ask for a global map using test map, which is just global map. We'll template it on string. And since this has to be a pointer type, let's use char stars for no reason. In fact, pointers to const char stars. So here we get to say we get a test global map, test map, default construct it. We will now check that test map dot lookup module non-existent, and the ID will be non-existent. This should exactly equal the null pointer. Test. Lovely. Lovely little testing suite. Then we get to say the next step here. We'll say will succeed lookup if the module will fail lookup if the item, if the key does not exist. We don't have a way to make that though. Actually, no, we do have a way to make that. We'll have a module called module, but we'll have a non-existent in here. So we'll say something like test map add to module key and the value test. Non-existent should equal null pointer. Very good. Succeed. Look up if both the key and module do exist. Key and module exist. So key test key auto pointer value is there. That's lovely. That's some very basic testing. And there's no way to, like, what is it? Check. It wouldn't be check throws. Yeah. Yeah. That's a basic test suite, huh? That's very interesting. This one, yes, but everything else, no. Commit. Sure that global map uses only pointer-like values. Test. Status. Ready to be committed. Add a test for the global map utility. There. Well, that was easy. I guess the next step is going to be to write one for test. What was the other thing I needed to write this for? It was scoped map. Big list. Scoped map test. Just in that list, yep. Then we get to say test scoped map test.cpp. floor. Let's go down one, and then we get to say source scoped map is here. V2. There we go. So scope map is really easy to work with, so let's just see what happens. We'll work on that later. Yep. Okay. This is I would say that the initial current scope of a scoped map is the root scope. Testing that's going to be hard though, because we don't really have a way to test such an invariant. This is one of those invariants that you can't, that I don't know how to test given our current public API. Ooh, there's a way to. And place returns a reference. I can use tricks. So the way to do that would be say using test scoped map is a scoped map template over strings and ints. No reason. Need some values to test, right? A way to test that is we would say auto entry is. We first need to create the test scoped map. Call it test map. Entry would be yeah, it would be better to have it as a vector, but that's a memory safety to do. Active value, no. Test map dot add to root string test, and we'll put the value at 5 initially. 5 is a magic number. Okay, very funny. But then what we will do is you'll say add to current scope test with a value of 10. Then we will say we want to check that the entry dot value is 10. Pair iterator actually no dot second arrow second. Rewriting all the packages. Oh, error. Non-const-del value to the reference pair cannot bind to... Huh? Okay. Non-const L-value reference to a type of pair cannot bind. Right, it's not returning references, it's actually returning whole pairs. Okay. Oh, we failed. Huh. That's interesting. Hmm. Probably some reasoning for this. Scopes are walked in reverse. So the way to check that the scopes are walked in reverse is we add to the root test of 5. No, we add to the root test of 3, or test of 2, and we'll go for auto scope is add scope please, and we will say scope dot emplace test, which will have 1. And then we will do a test map add scope dot emplace test of 0. Now for every scope in the test map. So for every scope in the test map, we're going to say int values we get to do values dot pushback scope dot at test. Yeah. What I want to check is there's probably a better way to write this with catch, but I do not know. I'll just use normal sorting from values.begin to values.end. Yep. 3 tests. Scopes are accessible from their higher, their child scopes. Let's call it that. Add root middle and top. Check that There's no API for that. Right. We don't do scope access. We just store them in a scope. Huh. So we can't actually do that. Huh. It's interesting. I forgot that I didn't support that. Huh. So, how do I fix this? Uh, I can always walk them in reverse. I think those two test cases are fine. Just to say that scopes are always walked in reverse and that and the initials, the root, that should be fine enough. Okay, so we have a failure here. Use rerun failed, output on failure. I remember who did this now. It's ctest bin. Rerun failed, output on failure. Okay. Huh. I thought it would overwrite. Unless the entry is doing something funny. Don't think it should be. Let's see. CVP reference, open up the map. When you do an emplace, you return an iterator. Whether the iterator to the inserted element or to the already existing element, nothing happens. Oh, we don't override that. We don't have a way to prove it then. We can't prove that the initial scope is that scope. Actually, no. All we can do is prove that it's the original value. Which also says something, which isn't just a proof of this, it's also, and, oh, no. Yeah. Well, I guess we can have another test that says, value inserted values cannot be overridden. That's the same test, yeah. Okay. Look at that. Let me check vector, because I don't like that I'm using vector, because it has iterator invalidation. Every time we call emplace back or pop back, well, pop back, element erased and end invalidate, which makes sense. But emplace back, if the capacity changes, all of them. That I don't want. Does Q? No, it was deck. Does a deck have better iterator properties than that? I don't think it does. You use mplace back, always invalidates. Nope, that's even worse. List. Here's actually a case where list may be useful. Does list invalidate iterators on mplace back? Or does list say we never invalidate iterators? An iterator is invalidated only when deleting the corresponding element. Okay. As long as I can reverse walk an iterator, yeah, I can reverse walk a list fast. So I should use list. List is preferable to vector. Referred to vector due to iterators. Due to the former, never indirectly invalidating iterators. It'll make cache locality worse, but we already use maps. Cache locality went out the window when we started using trees. I'll just write some commits from here. Git add test star. Commit. Add a test. Add tests for scope map. Git add source scope map. Commit immediately. Use list instead of vector in scope map. Order push. Okay. So that was one item off of my list. Not bad. Check. Huh. Now comes the question of what to do next. I've got a bike shedding issue. I've got 4 declared macros that I want to remove. The 4 declared macros I don't feel bad about now. It's a hack, but it feels like a hack that's useful. No literals. I could use that. How did I get around that in the type checker? Ah, right. I just stored null pointer. um. Well, actually, it makes sense here to use null pointer. So AST prim type null. Yeah. So I'm gonna go to source AST, and it's type.hpp. Source st type cpp. Prim type null. Type pointer null. Then it comes over here. Prim type null is a type pointer. I'm going to write a new prim type of AST prim type null. I added null there. It's there. Ah, yep, there's an error in type CPP line 115. It's good that it jumped there. Type null. What's up? Null. Building up all the tests. There. So now that we print that out, it can't be a pointer. Aha, that's good. So we can automatically distinguish it from pointer types because they take that. Okay. Actually, I can change that a bit. This should not just be a pointer type. This should be a non-nullable pointer type. In addition, I can use, what was it, stood dynamic putter cast? What was it? It was dynamic pointer, not putter. Welcome to C++. We abbreviate some things sometimes, but nothing all the time. Okay. So we test the pointer type, we then rip out the pointed to type, and yeah, that should be fine. Expected a non-null pointer at its argument, found this particular type. Boolean not. What do we check for a type being null? Statement. As to pointer types. Ah, yes. Instead here, still have that open, right? Yes. Oh yeah, I need to remove the PCHs, the precompiled headers. Hmm. Here, this is what I need. AST from type null. So if the left-hand side is the primitive null, we want to check that the left side is a nullable pointer. Um, if this is null pointer or this is not nullable, which what's the answer for the nullable types? Yeah, they return true, they return false. Okay. Left-hand side. There we go. So if the left-hand side is null or it is not nullable, yeah, only nullable pointers can be compared with it. Actually, wait. This will always be false, because by that point we know that. So, I want to see if Clang will, if compiler will pick that out. No. It's making some interesting assumption. Maybe Clang Tidy picks that up. I want to test this. Let's see, tools tidy. Now we get another spam of core usage while Clang Tidy boots up and decides that every file needs to be checked. Your hands off the keyboard every once in a while. Just, you know, good things. For everything. Let's see. That's in type checker. Type. User made types. I will fix that one day. I will fix these one day. Note, evaluation of comparison is deep. Well, function is cognitive complex. Yeah, okay. Ziptor type checker. I have to write some tests for the nullability ideas. Here. Pointer comparison. Now, left-hand side type is not literally null pointer, and that the right-hand side type is also not literally null pointer. There. I should have made that faster. I could have. I didn't. Actually, no, it could be on the side, on both sides. It could be a tautology, but I don't like people writing tautologies. Yep. Wait a moment, we need to check for the nullness up here. Other type. It's not that. Either of these is a pointer type. Yeah, I'm gonna have to check that. Find the type of, find the type of. Should be fine. Ninja test. All the tests pass. Tools. What was the tools again? It was test examples. Ooh, missing note stack implies. Huh. That's an interesting error. Let's try this again. Start.o missing. That is a weird error. Now I need to go Google. Warning. It's LD warning missing dot note dot new stack section. Let's see. Message from the compiler linker. It's never meant to be placed anywhere, so this warning looks like a linker bug. Size is only 0. Trampoline code. Wise. That's very odd. For now we'll be fine with it. This looks like nobody errored. Let's I will just commit, but only in patches. Yes, I want to commit that. Yes, I want to commit that. Yes, I want to commit that. Yes, this is a pointer type. Yes, it needs to be a static. No, I don't need that there. No, I don't need that there. Not yet. Add a AST prim type null to represent the null literal. Use the new null literal type representation. In the type checker. Don't worry about that. Look at that. Okay. So that's another thing off the to-do list. Bada-boo. Proper print error for parser and codegen. Well, for codegen, there's actually an interesting assumption here. Source. Am I in there? No, I'm down one level. Copy. Nope. Let's go build. Visitors. Codegen. HPP. So print error here takes the string for the error and then location. I kind of like the proper print error that I got off of the type checker, because that one I spent time on and actually care for. There we go. Yeah. This one you'll notice is templated. Type checker CPP. Source visitors codegen CPP. There it is. Right there. And then here, emit, and then exit 1. Now let's go for 42. Wedge number. Assert false. Location ice. Cool. Why is it an ice at this point? The buff 1. Any error here is some internal error that we should have caught earlier. Been checked. Type checked. And is correct. There we go. That's how we do the assert false here. It's now time to rewrite everything that ever used this print error. Okay, we don't need to plus it anymore. We need just the comma, but we need to know location. Let's see what happens if I make this. Oh. I have to look at that. But for right now, we'll do this way. Lock. Print error. Optional location. Source. Okay, yeah, just cleaning that out. Source, visitor, Cogent CPP. I'll have to read those errors later. Look at that, we don't need to do anything here. Const reference, because they're making it a const reference later. Next diagnostic. There. I should annotate that with no return, actually. No return. Attribute does not appear in the first declaration. Right, it doesn't. So if I come up here and annotate this, no return, that fixes it. Okay, next. Okay, so here, I think it's user val. I just love it. There's still been a floating point IR is not implemented warning here. Over all this time, I've never touched floating point numbers, so I can just not care. I'm just unable to care. Yeah. Oh, hello. Huh. Oh, sorry, I must have not done anything. Let me just see. Is my voice still right? Yeah. Huh. Hmm. Well, must have been too silent. Um, so okay. Well, back to my work. Location. Maybe I should get one of those things that puts the Twitch chat up on top of the those programs that puts the Twitch chat on top. Yeah, there. Then, oh, here we go with another one. comma there. To do a better exit strategy. Ah, I'll move that. I need to move that to do. That is still a correct thing. Oh. Yeah, we don't have location data here. Probably should store that, actually. Huh. Do a better exit. Store the location on the call data somehow. There we go. And then we get over here, and then we do the same thing where we say, this is creating a function decal. Yes. So get this here, get this here. We can delete that. Look at that. Oh yeah, C++, we had return 0. Yep. Okay. Unimplemented function typed identifier. This should be a null up. Yeah. May actually be useful later, but for right now it's fine to not care. Do better recovery. To do better recovery, it's a big joke. Let's see if this fixes it out. Oh, look. No function call for print error. This argument has the type of const, but this method is not marked const. Huh. That's interesting. We should be able to call this on a const version of ourselves. Additionally, I think it should be on a no except. Let's see if that fixes anything. Does not match the definition given. Okay. Const no except. That. So that did the work for there. Yeah, okay, so we have that, and then let me just check my volume. I think, yeah, I'm fine. Okay. So, now that we're printing errors correctly, if I run the test, I didn't change much of the logic, so I should be able to do if, oh, okay, we just come to patch restore. Yes, I do want to restore that. Nope, 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 nope. No, that's a fine comment to have, and no, that's a fine comment to have. Build and ninja. Okay. And now if I get to tools, test examples, same deprecation behavior, I'll be fine. same print error from. Maybe I should have my. Where's my followers? There's a followers thing, isn't there? Oh, isn't there like a list for active watchers? I'm getting absolutely distracted. Uh, edit. Hmm. I think it'll be fun if I don't have that. Yeah, that's interesting. Okay. Print error from type checker for node.gen. There. And look, even removed a few lines. That's always good. And you can remove 8 lines of code. Even if it's just formatting lines, sometimes that helps. God, I've been going at this for an hour and a part. Let's see. Could do. Oh, parser definitely should have a better print error. Do we have. Well, I need to go into build, and then I get to open up the new parser. Hmm. Yeah, I don't like having this error message thing. Yeah, this doesn't feel right. Do we use that anywhere? There are places where we use it. If the module's a null pointer, we print out the error message. In that case, error message fails. And a bunch of parses check that the parsing error message is empty. Actually, should the Lexer have a parser? It's always an interesting question. There may be a way for the Lexer to fail. That's important. Let's see, do we ever fail anywhere? So that would be finding. So if we find any instance of assert false. Yeah. Unknown escaped character. Yeah. There's yeah, here I think I can switch over to using a system of wait, no, not the parser, I want the Lexer. There are times when you need a Lexer error. So privately, Lexer should be able to have a, well, in a Lexer's case, I don't think it would be any useful to have it as a non-return, but I would want to do that. So let's say print error, keeping the style consistent. And this is over a const Lexer. And we want to take in, well, let's just template it because I don't want to care about all the args types, and then args types, args. Okay, so we get our arguments. Okay, so we get this, ever, that. And here we can get away with not storing the location because we have all the data for location ahead of time. So right after the destructor? Yeah, I'll put it right, oh, actually no, wait. Do we need to put it right before the destructor? Because here there's no failing. This is above, right above next identifier. Okay, so we'll put it, I'll put it here then. Template args team void print error lex error. Args types args. And then this is const. I need parameter args right. String stream. Take the string stream. What we pass in is args. Actually, wait. We don't need to string stream this. We can just dump it all to std error. C error. Well, the first thing C error should have is a line number. No. What it should do first is it should print out the file name, followed by single colon, followed by a line number, followed by a single colon, followed by a column number, followed by colon space, then followed by args. Ah, right. Thinks. Well, actually no. There. Operator overloading to the rescue. Until C error. Expression contains unpacked parameters args. True, it does. C error. I forget how I did that in the other cases. Hi chat, I'm sorry if I'm really distracted and it seems like I'm not interacting. I'm usually used to not being around, not having people listen to me while I write code, so just trying to get used to this whole I'm coding live thing. How did I do it for, I think it was in the visitor, the type checker, definitely. The CBP. Okay, that's how I did it. Right there. That's that. And then we will, for the Lexer, it should be fine to not care. So it should be fine for people to just for it to just continue on. Okay. Identifier. Insert false. Let's see, print error. Let's see what's happening here. What's happening here is we think it's a number. We then say we have a 0, and if we have a 0, we'll pass through. So it's a non-zero number. So it's not 0, but we do know it's a digit of some sort. But we know it's a decimal digit. Probably I should write this. In fact, we can assert that this is a digit all the way up here. Either we are hex or just 0. No. First 0. Not 0. Well, digit peak char. Ah, I see what's here. No. The next character is a dot. Well, here we can just say dot is unsupported, unimplemented. For digits, for numbers. Ta-da. And yeah, I'll just, no, there's a better way to say it. Flexing floating point numbers is currently unsupported. And for now, do a let's keep the old assert false, because at this point somebody should know. And this one I can just wrap in print error. Unknown escaped character. Print error. Right. This is actually, yeah, now I need to actually put this on the Lexer. So which should be a private thing. Escaped. Wait, this can be static as well, I think. Same. Do we ever use escaped anywhere? We should. Here it is. We escaped with next char. Escaped with next char. Um, Actually, this could be a, let's call it char next escaped. These aren't, and it's not const. Helper to handle escaping. Characters. To handle escape sequences. Yeah. If you have any questions, just ask. I really should update my, maybe I should update that. I'm unsure. Let's see. Escaped. Next escaped. Method can be made static. Yeah, but instead of taking C here, we'll take next char. Actually, no, we'll use C here, and auto C is next char. It will automatically call that, which will mean this happens. Yeah. So yeah, it is a fail. It is a compilation failure if you try to escape a character which is not possible to escape. I'm probably getting into a lot more than I should. This is probably not going to be a nice commit. Yeah, I probably could have moved that without doing all the work there. Conflicting type or print error. Right, it's conflicting type because don't need that. But I do need, yeah, I thought I could get away with this, but I cannot. Assert false, assert false. Assert that the peak is that, assert false. What is the error here? The error here is single pipe is not implemented. It's not a meaningful token. I think. Oh, yeah, unknown character, print error. Comma. There we go. Unknown character. Okay. Ninja test. All the tests still pass. We're going to get diff. See error. Okay. Proper print error function for relaxing. Yeah. There. 30 inserts. Well, kind of sad, but that's what I get. Now let's see what the parser is. Look. We have a print. Do we have a print error here? Source. Parser. We don't have a way to, well, oh yeah, here's the way we print errors right now is that we hand it over to, is we hand the error message to a parse, as we hand over the error message and let somebody else higher up parse it. That I don't think makes any sense to do. Or does it? That's the one problem here. I'm unsure. I'll have to think about that a bit more. But at least I got the cogen one done. IR, hand roll my own command line, proper built-in modules. Let's see. Am I missing something else? Like a proper unreachable? Unreachable? Yikes. Don't really want to... Well, wait. Was that for internal or external? Forget. I think that was internal use. May still be useful, but I'm not too thrilled to use it. Move syscall to make... Move syscall out to some module. That would be a bit of work to do. That would just be a bit of work to figure out. LLVM opaque pointers. I think, am I already on LLVM opaque pointers? Well, the way I could tell is if I go to, what is it, lower? Where's the dang thing? Location. Visitor, cogen, CPP. Assert that this is a pointer type. Don't I have a thing that lowers? I thought I had some sort of like lowering thing. Utils? No, it's not there. It's not AST. It's type context, that's what it was. Huh. No, I don't have that. I do have no way to tell these things. Well, I guess that's a thing. And then lambdas? I know for lambdas I can do the syntax. That I can do. I can definitely do parser.y expr. And where is it? Okay. So how would I do a lambda? Well, we could start with... Well, function header contains the thing, doesn't it? I forget what a function header contains. Function header is the function signature and the return type. A function signature has an identifier in it. We don't want the identifier because otherwise, because that would make it a named function. So we need to have so we start on a parameter group? Huh, interesting. Let's see. So we start on a parameter group, immediately followed by a, let's call it a ret type. And then we need the function body. Now function body is either an expression. Wait, yeah, here it is. Here's the function body. It's either a statement or an equal sign to an expression. So, if I were instead, actually, it would be better to write this as a separate thing. Lambda. And we'll say that a lambda is a parameter group followed by a return type followed by a singular statement, or it is a parameter group followed by nothing, well, t underscore assign and some other expression. Then if I say that this should be a lambda, does that make sense? I think his return type is an arrow to a type or it is nothing. That sounds like what I want. Because if you have a lambda that returns nothing, you should be able to write parens, open statement, and go. Yeah. We will always require the parens. Let's see what happens. Ninja Bison. Konfliktów. Nieużywane terminały. Stan. Could I use stan? Step 43. So, if you're at the end of a function call and you see an optional semicolon, either you can reduce the optional semicolon. Why would you want to shift it? Is this because you're declaring in... Huh. Yeah, that'd be interesting. Maybe I'd have to see the tree for it. State 90. The else reduction could be potentially messed up. Okay, what about state 145? One of these states has to make something... Ah, yes, here. Okay, this makes sense. So they're saying here that a lambda is not possible because it will try to assume things, it will try to shift in things, or it will try to reduce it via lambda rules. I think we want to shift it in. And the way to do that is to, I think we would give it the precedence of the if expert. That is the weakest precedence. Does that make sense? Yeah. Should have the weakest precedence of them all. Dana del símbolo. One second while I fix the environment here. Because apparently, I was to understand. Rule given for lambda, which is actually a token. What do you mean lambda is actually a token? Oh, I forgot a semicolon. Rule given for lambda, which is a token. Where? Ah, right, because precedence. Ah, I see what's happening. This percent. Okay. Precedence here. Did they get worse or did they get better? That did not change. Excellent. So let's see, what if I do that to these rules? If I say that these rules should have such a thing. Two conflicts only. Which I want to read the report for. State 43 has some conflicts. What was my thing for slash user slash patient? Yes, I want to generate counterexamples, please. Okay. So for the function call, what it's saying here, for the function call one, is it saying, what if you have a lambda in a return statement? If you have a lambda in a return statement, either if you have a lambda in a return statement and the next thing is a semicolon. So something like I need to copy this. Yeah. Right. But you see here we have actually wait, we can do that. Pipe into vim hyphen. Well, that really doesn't work. It's all mangled. Oh, okay. But I'll try and explain the point here. So I'm just going to copy these two. I'm just going to copy both of them. Paste. Okay. So first thing here, we have a shift reduce conflict. So first item here is a shift reduce conflict on a semicolon. Because what's happening is we're getting some example like, to give this example more clarity, we are saying something like return parameter group, return type, which could be empty, and then some function call, foo, and then there's this semicolon here that may or may not be us, because this semicolon could either be the close of the return, which is what this first guy here is, what the second guy here is saying. It could be the close of the return, and in that case, this dot has to generate empty because the function call needs to end on something. Or this is or there's actually another semicolon down here. There's actually another semicolon down here. In that case, we should consume this semicolon so that the next one is not hanging. You could argue to simply check for two semicolons, but I would prefer not to. Especially with Bison liking only one ahead. So here, this is saying, oh, if you have, it's a very interesting example here. These are the same example, right? Shift reduce. This argues that if you have a lambda, some return starts on an if x then, followed by a statement block, else followed by a foo, else followed by y, right? By y, and you're at this else. It could either be the case that That's interesting. Let me just reread my grammar to be sure that I'm not missing something. Statement block, return statement, let statement. So it's saying here is that the statement of the lambda is an if, inside of which we have the statement block So one suggests, I know what it's suggesting. The first case is suggesting, so the first case suggests that we actually have something like this, where this if else is joined. In this case, we're suggesting that the if else should not be joined. And that's that. The curly braces there we can call pseudo curlies. Basically, how it would group if it weren't some other way. And why would this make any sense? I don't know. Compiler assumes that it could. Right. So the problem here is the precedence of else. It's tricky. And the optional, and the fact that the semicolon's optional in a function call may cause it to be weird. So, it's a very interesting question what to do with this. I could just say that a lambda has to have curly braces. That would disambiguate everything. But I really do like having lambdas that aren't curly brace closed. Sad. Very sad. Very sad. This is what I get for pushing the syntax of pushing a kind of horrible syntax this far. Statement, right. Well, I could give this the precedence of lambda decal. Lambda decal. And then expr. Lambda decal. Let's see if that fixes anything. Nope. Control Z. Probes. Kill %1. And while we're at it, do not attempt this. Same issue still happens, it seems. I may just have to say that this needs to be a statement block, which is sad. but it works. Yeah, that's kind of sad. Very sad. Lambda exists. Go to state 76, they say. Atom reduces to lambda. But how do we create the lambda in the first place is my real question. Ah, here we are. State 73. Return type. State 155, which then takes an expression. Or we go to state 116. Yeah, and that just does that. State 146. State 31, which goes to a statement sequence. Yeah, so effectively by making it curly braced, it disambiguates the whole thing, but I wanted to be able to write lambdas not so weird. Now just removing all the tabs out of here. That feels so sad, you know, that like I have to write lambdas with curly braces. It's unambiguous, but I wanted a terseness to it. It's kind of sad, yeah. Well, yeah. Well, I guess on that kind of dull note, I'll end the stream. It's been 2 hours. Yeah. Well, thank you everyone for being here. Will I'll don't know when I'll be back. See ya.